Today we're going to talk about a special theorem in math that goes with any exterior angle of a triangle. What do we mean by an exterior angle? Say that we were to take the line segment BC and extend it on past the edge of this triangle. That would create an exterior angle on the outside of the triangle. We are about to look at an animation of an 180-degree rotation around the midpoint of triangle ABC's side, which is labeled point R. This is the same experiment that was done in Lesson 5 when we were learning about the triangle sum theorem, which is that all triangles' interior angles add up to 180 degrees. When the triangle is rotated around point R, which is the midpoint of one of its sides, it creates a parallelogram. If we were to do this rotation one more time around point S, which is the midpoint of the side, it now creates a trapezoid. Looking at the bottom where all three angles have been lined up on a straight line, we can verify our triangle sum theorem again, because the orange angle, the blue angle, the green angle, and the purple angle all add up to 180 degrees on the straight line, and those were the original angles that were inside of the first triangle, the purple, the green, and the orange. However, in this video, we are going to be investigating the exterior angle that we just created. Let's outline triangle ABC that we started with to make it more clear. You can now see that there is an exterior angle created on the outside of the triangle that is made up of a green and a purple angle. If we look back at the original triangle ABC that we started with, the two remote interior angles were also green and purple. Making that noticing will help us learn the theorem for the exterior angle of a triangle. These are called remote interior angles because they are not adjacent to the exterior angle, which means that they are not touching the exterior angle. This is the theorem for the exterior angle of any triangle. The measurement of the two remote interior angles, if they are added, will equal the measurement of the exterior angle. So in this diagram, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Let's look at an example. How would we find the answer for x? How would we find the exterior angle? We could set up an equation to help us solve. Adding the two remote interior angles will give us a value for the exterior angle. In this case, the exterior angle of this triangle measures 149 degrees. Let's look at another example. This time we've already been given the exterior angle measures 130 degrees. We are missing one of our remote interior angles. How could we set up an equation for this? The rule still applies. If we add the two remote interior angles, which are 60 degrees and x, that will be equal to the exterior angle, which measures 130 degrees. In order to solve for x in this case, we would have to subtract 60 degrees on each side. What is the measurement of the other remote interior angle? You got it! The other remote interior angle is 70 degrees.